Hello, my name is Stuart Hales and I will be presenting the sv9100 Voice over IP migration webinar. This webinar should help sv8100 trained engineers gain an insight into some of the main changes for Voice over IP when migrating from an sv8100 to an sv9100. For this, we're going to focus on the following areas: Voice over IP system hardware, new sv9100 features, IP extensions, IP trunks, networking, IP DECT, PC Pro, training and documentation. So let's begin with section 1, an overview of the sv9100 system hardware. The sv9100 is part of the UniVerge sv9000 family of distributed IP SIP systems. It has increased capacity to support up to 896 IP stations. Also, there is increased capacity to support up to 400 IP trunks. With the sv9100, there is now support for multiple SIP carrier configurations on a single system. Previously, on the sv8100, you would have to have netlink nodes to be able to do this. There is also support for a full new range of DT800 IP terminals, along with backwards compatibility with the existing DT700 range of handsets. Seamless distribution across the network as a single system using the netlink protocol, and also supports network connectivity to other systems and backwards compatibility using AspireNet, KCCIS, SIP trunking, and H323 networking. So what Voice over IP connectivity does the UniVerge sv9100 support? An sv9100 connected to an IP network, as you can see from this slide, has a range of applications available to it. For example, we can use IP trunks to connect to an external SIP carrier, and with the new SIP multi-profile feature of the sv9100, we can now connect to two carriers at once on a single system. Also, using IP trunks, we can connect to a SIP-enabled PBX for internetworking, such as an SL1100. We can connect to other NEC PBX platforms, such as the sv8300 and the sv9300 using KCCIS networking, and we can connect to the sv8100 using AspireNet networking. Netlink is still available on the sv9100, but it is only for sv9100 systems, so you can't netlink an sv9100 to an sv8100. On the IP extension side, we've got the DT800 range of handsets, and also for backwards compatibility, we support the DT700 handsets on the sv9100. These are SIP MLT devices. We also support standard SIP devices such as the UT880, Baseline Pro SIP, and Polycom devices on the sv9100. IP DECT is supported the same as it was on the sv8100, and for voice over wireless LAN, we've got the MH150 handset, a new SpectraLink 8400 handset, and also for bring your own device, we've got the NEC U-Mobility client, which can be connected directly to your sv9100 system as a SIP extension. Finally, there is an IP soft phone, the SP310 application, which can be installed on a PC. So looking at the system hardware of the sv9100, there is a new CPU, which has improved processor speed and also an increased memory capacity. So you no longer need a PZ-ME50 anymore. Also, there is a built-in voicemail interface and modem, so no longer do you need the PZ-VM21. And there is an SD card for the storage media of main software and also the voicemail and VRS announcements. There's two types of SD card available for the voicemail and the main software storage. There's a 1GB card, which gives you approximately 12 hours recording time, and also a 4GB card, which should give you around 115 hours. But most importantly on this slide, there is a new voice over IP card called the IPLE, which is mounted on the CPU in the same way that you used to mount the IPLA or IPLB on the CPU of the sv8100. So looking at the bottom part of this slide, you can see the differences between the CPUs of the sv8100 and the sv9100 more clearly. So the card is simply changed, but the main software is now installed on an SD card, which sits on top of the CPU. PZ-ME50 and the PZ-VM21 are no longer required. They're now built into the actual sv9100 CPU card, and the compact flash card for the in-mail on the sv8100 is no longer needed. That software is now on the SD card as well. This slide gives a comparison of the sv8100 and sv9100 CPUs with their technical specifications. You can clearly see that the sv9100 CPU has been increased performance-wise considerably. Notably, you can see that the microprocessor instructions per second, the data bus, system bus and main memory bandwidth have all increased. At the bottom of the slide, you can see that the front panel of the CPU on the sv9100 is very similar to the CPU front panel on the sv8100. The new VoIP DB card on the sv9100 is called the IPLE. It's mounted on the CPU in the same way that the old sv8100 VoIP cards were installed. The IPLE differs from the IPLA and IPLB on the sv8100 in that there is only one variant of the card available, which gives it a maximum potential capacity of 256 channels. However, on the IPLE, these channels were only available through licensing. To make this clearer, if you look at the table at the bottom of the slide, the sv8100 had the 32, 64 and 128 channel cards available. On the sv9100 we only have a single IPLE card. Initially it will come with 4 IP trunks and 4 standard SIP terminal licenses available, but to increase the capacity on the card you have to buy IPLE channel capacity licenses, potentially up to a maximum of 256 channels. The IPLE also provides video capability, so we can use video streaming termination and also a simple MCU with video functionality. This slide shows a comparison of the IPLE on the sv9100 to the IPLB that was available on the sv8100 and the technical specifications. You can see that the IPLE on the sv9100's performance has been increased. The number of DSP cores on the IPLE has been increased to 24 over 6 on the IPLB. The maximum voice channels available on the sv9100 IPLE is 256, whereas the maximum available on the IPLB was 128, and also video support is available from the card on the IPLE, whereas before on the sv8100 video calls were only supported using peer-to-peer between standard SIP extensions. This slide gives an overview of the codec and features support for the IPLE. Down the left hand side you can see the codecs and features listed, and along the top it displays the devices and networking protocols supported. So the matrix shows you what codecs and features are supported for each device and networking protocol. So all devices and networking protocols support G711 codec usage, also G729 and G722. G726 is not supported by DT800 or DT700 extensions or AspireNet. SRTP for encryption of call traffic is only available on DT800 and DT700 extensions, and peer-to-peer calling is supported on all devices and networking protocols except for IP trunks H323 and AspireNet. Video functionality is limited to SIP extensions and also IP trunks when using SIP. NAP functionality for connecting a SIP extension or a DT800 terminal is supported, and also NAT when using IP trunks using SIP is supported. VPN connection can be used for any of the devices or any of the networking protocols. This slide gives an overview of the IPLE codec channel capacity. The maximum number of channels is limited when using SRTP with any given codec. So you can see from the table below that for all codecs the maximum RTP channels can be 256 with an IPLE card. However, if SRTP is used for a DT800 or DT700 terminal using one of these codecs, the actual channel capacity available is reduced to 230. Also, G723 and ILBC codecs are no longer supported on the IPLE, and RTP forwarding is also no longer supported. System hardware capacities of the sv9100. The system is expandable up to a maximum of 1,360 total ports, which are spread across trunks and extensions. However, 64 of these ports are always reserved for voicemail usage. Looking at the VoIP functionality, you can see that for trunks we can have potentially a maximum of 400 IP trunks. For IP extensions we can have a maximum of 896. When using NetLink we can have a maximum of 49 secondary nodes connected to a primary system, and you can see that the VoIP IPLE channel's maximum capacity is 256. Let's now look at SV8100 to SV9100 migration. Hardware migration to an SV9100 from an SV8100, the following parts cannot be used or migrated to an SV9100 system: the PZVM21 for in-mail flash card, the ME50 memory expansion, the processor card of the SV8100, and also the variants of the IPLB card 32, 64, 128 cannot be used in the SV9100. At the bottom of the slide are various other parts from an SV8100 system. for example the digital terminal cards, analog trunk cards, etc. These can be used in an sv9100 system if you install a hardware migration license. But be aware that sv8100 cards are blue and the new sv9100 cards are black. sv9100 cards can be used in an sv8100 system and there's no license required for them to do so. The two tables list the supported cards on an sv8100 system. So if you wanted to migrate an sv8100 system to an sv9100, you need to change the CPU and install a hardware migration license. Then all your sv8100 optional cards should work on the sv9100. Once this is done also, DT700 terminals could be migrated from your sv8100 system to the new sv9100 also. Just to be clear on terminal migration from sv8100 to sv9100, the DT700 range of handsets will work on the sv9100, and similarly DT800 range of handsets will work on an sv8100. If we have completed the hardware migration from an sv8100 to sv9100, we can then migrate the sv8100 configuration file. This can be done from a saved PC Pro backup file. Open up the sv9100 PC Pro, drag and drop or open the saved sv8100 configuration file, and then connect your sv9100 and upload. Change the time settings on your system and disconnect. Once this is done, your sv8100 configuration will be migrated to the sv9100. Also load any required licenses to complete the migration and re-record any VRS or in-mail messages. sv9100 voice over IP licensing. System capacity licenses. With the sv8100, when you purchased a CPU, you got 64 ports available for TDM devices. To increase this capacity, you then had to purchase an ME50 card which would give you 128 ports. Then it moved to licensing. You could purchase either a 256 port or an unlimited port license which would give you the maximum port capacity of that system. Moving to the sv9100, port capacity licenses are treated differently. With the new CPU you still get 64 ports available. However, from that point onwards, you purchase port capacity licenses individually, and these are also used not only for TDM devices but also for IP trunks and also IP extensions. The port capacity license on the sv9100 is BE114042. IPLE channel capacity licenses. With the sv8100, channel capacity on the IPL card was determined by the size of the card that you purchased. You could get either a 32 channel card, 64 channel card or 128 channel card, and these channels could be used for IP extension calls to IP trunks, TDM extensions and trunks, or networked systems. With the sv9100 and IPLE card, all 256 resources are available on the card. With the new CPU, 8 of these resources are immediately available, 4 for IP extensions and 4 for IP trunks. If you wish to add additional devices to your system, then when you purchase those devices, either IP extensions, IP trunks, or networking, they will include an IPLE channel license. This slide lists our voice over IP feature licensing codes. Starting from the top down, we have BE114042, which is our system port license. If we wish to add IP devices which will utilize system ports that don't come with our 64 ports on the CPU, then we will need to add additional system port licenses to our system. BE114497 is an IP phone license specifically for DT700 and DT800 terminals. BE114054 is another IP phone license for the standard SIP devices, so for your Polycoms and also for the NEC IP deck terminals. BE114058 is a softphone license for the SP310 softphone. BE114065 is an IP trunk license used for SIP or H323 trunks. BE114066 is a networking license which can be used with either a SpyNet or KCCIS. BE114067 is a netlink node license for secondary nodes connected to a primary. This license also comes bundled with 32 IPLE channel licenses. BE114068 is an encryption license for allowing RTP encryption between DT700 or DT800 terminals, and BE114070 is the video feature license, which allows video termination or simple MCU usage. sv9100 new voice over IP features. New voice over IP features of the sv9100 include IPLE DSP round robin allocation, performance improvements of the DT700 and DT800 terminals, port-based peer-to-peer assignment, IP trunk assignment enhancement, SIP multi-carrier support, video streaming termination in simple MCU, conference call support by standard SIP terminal, and conference key support for standard SIP terminal, and 7-color LED display notification by caller ID. We're going to look at each of these features individually. IPLE DSP round robin allocation is a new DSP resource allocation method with the sv9100. The current sv8100 method for allocating DSP resources is to look at the lowest DSP resource number and check if it's available. If it is available, then this will always be selected. If the resource is busy, then the next lowest DSP resource will be checked, and so on. This can mean on some systems that the lowest DSP resources are always in use and is not particularly efficient. sv9100 DSP round robin resource allocation method will initially use the channel with the lowest number and save that channel as a pointer. Next time, the system will search for the next available channel from the pointer used previously. Because of the DSP round robin allocation method, when using port forwarding configured on a router for either SIP trunks or NAT extensions, for example, ensure you have enough DSP resources open for your voice and video calls. If you wish to open up the full capacity of an IPLE card for voice, you need to ensure that ports 10020 to 10533 are open for RTP. For video, open ports 20020 to 20533 again for RTP. Performance improvements of the DT800 and DT700 terminals. With the increase in specification of the CPU and IPLE card in the sv9100, improvement of the terminal display and key updates is around 14%. Voice connection on IP terminals when paging to a group containing a digital terminal is also improved by around 4 to 5%. And finally, voice connection speed from the time an outside line arrives at the system is improved by around 1%. Other enhancements for DT800 and DT700 terminals on the sv9100 coming from the sv8100 are to do with function keys. On the sv8100, this list of function keys should not have been set on more than 30 IP terminals simultaneously. With the sv9100, that capacity has been increased to 100 terminals. Also, internal paging on IP terminals. With the sv8100, the maximum number of IP terminals assigned to a paging group was 16 terminals. This has now been increased on the sv9100 to 50 IP terminals. And finally, the registration process of DT800 and DT700 terminals. On the sv8100, the system could only process 20 registrations at once. With the sv9100, this has now been increased to 50 registrations. Port-based peer-to-peer assignment for IP terminal. With the sv8100, peer-to-peer operation for IP terminals was controlled by system-based settings for DTerm IPs, DT700s, or standard SIP devices. On the sv9100, peer-to-peer connection has been opened up for IP terminals so that they are now controlled by a port-based setting. With this enhancement, if the system uses OAI or CTI applications such as BCT or UCB, along with standard SIP devices for example, the UCB or BCT devices can have peer-to-peer disabled. However, the other standard SIP devices can still continue to make peer-to-peer calls. The new setting for peer-to-peer mode has now been moved from 1026 to PRG 150550. IP trunk assignment enhancement. This applies to SIP trunks, H323 trunks, and KCCIS trunks in peer-to-peer mode. With the sv8100, you often saw an issue when allocating KCCIS trunks and SIP trunks being used at the same time. The system would always assign the KCCIS trunks, then SIP trunks, even if the SIP trunk ports had already been assigned, so effectively replace the SIP trunks with the KCCIS trunks. Also, IP trunk ports could not be assigned when a VoIP DB card was not installed in the sv8100 system. With the sv9100, a new IP trunk assignment system removes the sv8100 limitations. IP trunk assignment enhancement conditions. IP trunk ports can be assigned by each trunk type, so either SIP, H323 or KCCIS. When the system assigns the IP trunk ports, the system will check the port's condition first. The system will search for available ports from the specified port. When available ports are found, the system then assigns the IP trunk ports. The user can assign IP trunk ports regardless of installed licenses. When the user uses IP trunk, the license will be checked. If the licenses installed are not enough, then the system will report this in the system alarm report. When a user sets either the trunk type, start port, or number of ports to 0, the IP trunk port assignment will be cleared. You can configure up to 10 IP trunk port ranges on a system. You will see in PC Pro, but if you're trying to configure IP trunks on a single system, use Netlink ID 00 to assign these. In a Netlink deployment, you will use Netlink IDs 1 to 50 to assign your IP trunk ports to the system nodes. This slide is a screen capture from PC Pro of one of the new pages where IP trunks can be assigned. You can see down the left hand side here the Netlink system IDs. So if I was configuring a single system, then I would just configure Netlink system ID 00, but if I was configuring a node in a Netlink environment, I would configure Netlink system ID 1 down to 50. You can also see the 10 different trunk ranges that you can configure on a single system. In this example here, I've configured two different trunk types, one for SIP, starting from port 1 and a number of ports of 5, and then a second trunk type for CCIS, starting from port 6 and again for 5 trunks. Once these are applied, you can then go back to the blade screen and check the trunks assigned to the system. And as you can see from this section taken from the blade screen here, I've got IP 6 to 10, 5, which is my CCIS trunks, and then I've got SIP 1 to 5, which obviously are my SIP trunks. This screen is also useful for IP trunk assignment. This is the SIP trunk data setup screen, and you can see here the trunks that have been assigned in your system. So from the previous slide, we assigned ports 1 to 5 to be SIP, and then 6 to 10 to be CCIS, and you can see those assigned on this screen here. Also from this screen, we can enable peer-to-peer mode for when doing SIP trunks in inter-networking to be able to make calls between SIP extensions peer-to-peer, and also video mode to be able to send video calls across a SIP interconnection. Also, when we're using SIP profiles, this screen is really important because this allows us to assign the IP trunks to the different SIP profiles. So by default they are all assigned to profile 1, but if I wanted to, I could assign a couple of these SIP trunks to be used by profile 2. SIP multi-carrier support. The sv8100 system can only configure a single SIP configuration. This can be restrictive when wanting to use a SIP carrier but also SIP internetwork to another SIP enabled PBX. The only option to be able to do this is to use a Netlink configuration, with the SIP configuration to the carrier on the primary node for example, and the SIP internetworking configuration on a secondary node. The sv9100 can now configure two SIP profiles on a single system without Netlink, so you can use a SIP system interconnection and a single SIP carrier, or you could use two SIP carrier configurations at the same time. There are three limitations to be aware of with this feature. The first is that a different value for the SIP port on the sv9100 needs to be assigned to each profile. So by default, profile 1 uses port 5060 and profile 2 uses port 5062. So when configuring port forwarding on your router, you need to adjust for these values. The second limitation is if connecting two carriers. They must both be accessible using a single route because the system can only set one default gateway in 10.12.03. And the third limitation is the SIP stack cannot separate DNS server settings between the two configured carrier profiles, so cannot use two carriers that has to use different specific DNS servers at the same time. This slide shows an example of a SIP carrier and SIP internetworking configuration on a single sv9100 system. As you can see, both destinations must be accessible through the same default gateway programmed in 10.12.03. This example illustrates two SIP carriers connected to a single sv9100 system, and again, both carriers must be accessible through the same default gateway and also utilize the same DNS server settings. Some conditions to be aware of when using the SIP multi-carrier feature. SIP trunk ports are assigned to a SIP profile. Programming command 141805 will allow you to do this by selecting one of the SIP profiles for the SIP IP trunks that have been assigned. The below programming areas are modified to select between the SIP profiles being configured. Programming area 1028 for SIP system information setup, 1029 for the SIP server information setup, 8413 for the SIP trunk codec information basic setup, 8414 for SIP trunk information basic setup, 1036 for the SIP trunk registration information setup, 1412 for SIP register ID setup for IP trunk, 1516 for SIP register ID setup for extension, and 2119 for the IP trunk calling party number setup for extensions will all allow you to select between either SIP profile 1 or SIP profile 2 from now on. Only a single SIP carrier configuration can be set on a NetLink secondary node, so it can only use profile 1. Profile 2 is not used on a NetLink secondary node. This slide details the limitations we mentioned earlier to do with the SIP multi-carrier feature. The first one of these is to do with the SIP trunk port number. Each profile must have its own unique SIP trunk port number. For example, profile 1 by default has a value of 5060, whereas profile 2 by default has a value of 5062 in programming command 841406. This is the listening port that the system uses, and when messages are received on those ports, it knows then which carrier configuration to use. The next limitation is with the default gateway. When two carriers are connected to the sv9100, they must both be accessible through the one default gateway programmed in 10.12.03. The third limitation is DNS server. The SIP stack cannot separate DNS server information, so if using two carriers, they cannot have separate DNS server settings at the same time. They must both use the same DNS configuration. The next few slides are going to go through and illustrate a SIP multi-carrier example. So we've got an sv9100 system which is going to connect to an external SIP carrier, but at the same time use a SIP interconnection to another SIP enabled PBX. So SIP profile 1 is going to be our SIP carrier configuration, and SIP profile 2 is going to be our SIP interconnection. The next three slides go through the programming steps required for configuring this type of example. You can pause the video to look at these programming commands in more detail. This is slide 1, slide 2, and slide 3. When programming SIP carrier configurations on the sv9100, the majority of programming items can be found under Advanced Level Programming at Advanced Items, Voice over IP, General Settings, and IP Addressing. Under here you can configure the CCPU and IPL IP network setup. Also you can configure the IPL Voice over IP resource IP addressing. You can also go to Advanced Items, Voice over IP, Networking, SIP Networking, and then the rest of the SIP carrier commands are listed under here. So we have the page for SIP IP trunk assignment, SIP trunk data setup for assigning either profile 1 or profile 2 to our IP trunks, and then we have our actual SIP carrier configuration pages which are listed under SIP trunk general settings, networking mode, carrier mode IP address, or carrier mode domain name, depending on the carrier configuration that you're setting up. First we're going to configure profile 1 for our SIP carrier configuration. The first thing we need to do is configure our IP network settings. This can be done at Advanced Level Programming underneath Advanced Items, Voice over IP, General Settings, IP Addressing by selecting the page CCPU IPL IP Network Setup. The items configured on here from the list of programming commands on the previous slides is the default gateway, the NAT router IP address, and the IPL IP address and subnet mask. The next page still under Advanced Items, Voice over IP General Settings IP Addressing, is the IPL Voice over IP Resource IP Addressing. This is where we can configure our DSP gateway IP addresses for the IPLE card. So in here, we only configure a single IP address for all potential 256 DSP resources on the IPLE card. So we set the VoIP-DB DSP IP address to our network configuration settings listed on the previous slides. The next step is to assign our SIP IP trunks. So we can do this underneath Advanced Level Programming at Advanced Items, Voice over IP, Networking, SIP Networking. The page we open is SIP IP Trunk Assignment, and because we haven't got a netlink configuration, we're going to configure the SIP IP ports underneath netlink system ID 00. So you can see on this slide here that underneath setting number 1, we've assigned the trunk type to SIP, we've set the start port to 1, and then we're enabling 16 SIP ports. Next, we need to split our IP trunks between SIP profile 1 and SIP profile 2. So this is done on the SIP trunk data setup page, which is still found underneath Advanced Items, Voice over IP, Networking and SIP Networking. As you can see here, what we have done is assign trunks 1 to 8 to SIP profile 1, but then trunks 9 to 16 have been changed so that they are now assigned to profile 2. Now we are going to program specific profile 1 SIP carrier settings. So underneath Advanced Items, Voice over IP, Networking, SIP Networking, we select profile 1 and then we go to SIP trunk general settings and SIP trunk incoming type screen. In here we can set our incoming trunk type to DID to route our calls through the DDI routing tables. Also we can assign our SIP IP trunks for carrier profile 1 to a specific trunk group. In this case here, we've assigned them to trunk group 3. Now we can configure our specific SIP carrier settings. So still underneath Advanced Items, Voice over IP, Networking, SIP Networking, Profile 1, we've now selected the Carrier Mode Domain Name section because we're trying to connect to our SIP carrier using a fully qualified domain name. So the first page we're going to configure in there is the SIP System Information Setup. With this particular carrier, we're setting our domain name to carrier xyz.co.uk, setting the host name to SIP, and we're setting the domain assignment to domain name because we're using a fully qualified domain name to connect to. We then go to SIP Server Setup underneath Advanced Items, Voice over IP, Networking, SIP Networking, selecting Profile 1 and underneath the Carrier Mode Domain Name section. On here, because we're sending a username and password to the SIP carrier, we enable register mode, and because we're using a fully qualified domain name, we need to use a DNS lookup to be able to find the IP address from this. So we enable DNS mode and enter a suitable DNS IP address. The registered domain name is from the SIP carrier and is entered as sip.carrierxyz.co.uk, and then the SIP carrier choice for that carrier is selected, so in this case carrier A. Because we're using a NAT router, we enable that on this page also. We can now enter our account authentication settings for the SIP carrier. This is done still under Profile 1, Carrier Mode Domain Name, on the primary authentication information screen. If you have a single account for a SIP carrier, the details are entered in this screen. Multiple accounts can be entered on the multiple authentication information screen. So enable the registration and then enter in the user ID and authentication user ID, the account ID provided to you by your SIP carrier. Also then enter the authentication password provided again by the SIP carrier. For sending CLI from your extensions using this profile, this can be configured still under Profile 1, Carrier Mode Domain Name, on the SIP Calling Party Number for Extension screen. So just enter the CLI that you want to be presented when making outbound calls from that particular extension on your system. At this point, for making outbound calls, we can check our trunk access code and trunk group routes to make sure that we're picking up the correct trunk group for making any calls when we dial that trunk access code. So system numbering plan, system numbering can be used to check your trunk access code by checking the first dial digit, setting the dial digit length to 1 for example, and then setting the type to trunk. The dial digit is normally 9 or 0. And then for trunks, trunk group routing, trunk group route, by default the routing table will look at trunk group 1, but because we've assigned our SIP IP trunks to trunk group 3, we just need to change table entry 1 to 3. So now, all being well, profile 1 is configured to connect to the external SIP carrier, and we should now be able to dial our trunk access code and dial a number straight away to that carrier. So now we're going to configure profile 2 as a SIP interconnection to another SIP enabled PBX. So underneath advanced items we go to VoIP, networking, SIP networking, select profile 2 and then go to SIP trunk general settings and the first screen SIP trunk incoming type. On here what we're going to do for incoming calls is set the IP trunks assigned to profile 2 to tie line so that the incoming calls use a system numbering plan. So trunks 9 to 16 are assigned to trunk group 5 and modes 1 to 8 are assigned to tie line. Next we can assign a user ID for our profile 2. This is used as a system CLI presentation for if no CLI is assigned next to any extensions or any trunks under profile 2. This can be set under profile 2 by going to networking mode, SIP system information setup, and then assign the user ID to a value. It could be a descriptive value of the location of where the system is installed, or it could be something simply as sv9100 for example. We can now program our remote destinations information. Still under profile 2, networking mode, we go to the SIP remote destinations page. We're only connecting to one SIP enabled PBX, so we enable system interconnection for system number 0001. We enter the IPL IP address of our destination system, so in this case 172.16.20.10, and then we enter the prefix dial number for calls routed to that system, so in this case digit 2. On the far right we enable the remote destination for the SIP profile we want to use, so we're using profile 2, so that is selected. Next we can configure the SIP carrier choice for our SIP interconnection. Normally this is set to carrier B. This can be configured still under profile 2 networking mode on the SIP server setup screen. So select SIP carrier choice and set it to carrier B. We can now configure our system to route calls to the remote destination. This uses a combination of the system numbering plan and froute programming. You will notice that this is a big change from the sv9100 PC Pro, in that underneath the networking mode programming area these commands have been brought in to make it easier to set up. So still under profile 2 we go to networking mode, SIP numbering plan, system numbering. Because the remote destination is using the 2XX range of extension numbers, we're going to set first dial digit 2 to a dial digit length of 3 and a type of froute. We can also check that our local extension number range is correct by going to profile 2 networking mode, SIP numbering plan, extension numbers. In this case we're setting our own system's number range from 100 to 199. We can now configure froute so that when 2XX digits are dialed, the calls are routed to our IP trunks on profile 2. So still under profile 2, networking mode, go to SIP numbering plan, froute, dial analysis, table lead digits page. Underneath table entry 1 we're going to set the dial digits to 2, the service type to froute, and underneath the additional data column set the value to 1. Next we go to the froute table screen, still under profile 2, networking mode, SIP numbering plan and froute, and in here underneath froute table 1 we set the trunk group to 5 for our IP trunks assigned to profile 2, and we set the maximum dialing digit to 3. This is because the maximum digits dialed is 3 to the remote destination, and it prevents the user from having to dial a hash after the number to send the call immediately. To send our extension number as CLI, we can do this under profile 2, networking mode, SIP calling party number for extensions, and you can just copy and paste the extension column into the SIP extension calling party number column. So now, all being well, after following those programming pages, We should now have a SIP profile 1 connected to a SIP carrier, so we can make external calls to the PSTN, but also we should have SIP profile 2 set as a SIP interconnection to a remote destination for intersite calling on a single system,